You can build a shelter out of frozen water, step inside it during brutal winter weather, and end up warmer than you were standing outside. That sounds backwards. Snow is cold. Ice is cold. So how can a house made almost entirely from snow help keep your body warm? The answer is that an igloo does not win by creating heat. It wins by controlling where your heat goes. And once you understand that, an igloo stops looking like a primitive snow hut and starts looking like a giant insulated jacket built around the human body. Think of your body as the warm object inside a thermos. You are constantly producing heat, and in a cold environment, that heat is constantly trying to escape. The real survival problem is not simply that the air outside is cold. The problem is the speed at which energy can move away from you. Slow that transfer down, and the heat your body already produces becomes much more useful. Speed it up, and even a powerful heat source can struggle to keep up. An igloo changes that race. We are going to break this down through 7 layers: the snow itself, the trapped air, the wind barrier, the enclosed space, the shape, the entrance, and finally the human heat source sitting inside it. Put those pieces together and you get one of the most elegant examples of insulation in the natural world. First, the strange material, snow. If you wanted to stay warm, snow probably would not be the first construction material you would choose. Touch it with your bare hand, and heat immediately leaves your skin. Hold enough of it, and your hand becomes painfully cold. So the obvious conclusion is that surrounding yourself with snow must make the problem worse. But that confuses temperature with heat transfer. Something can be cold and still slow the movement of heat. That distinction is the entire secret. Imagine wearing a thick winter jacket that has been sitting outside. The jacket itself may initially be cold, but you do not expect the jacket to generate heat. Its job is different. Your body produces the heat. The jacket creates resistance between that warm body and the colder environment. An igloo works on the same basic principle. The snow wall is not a heater, it is insulation. The U.S. National Park Service describes snow as a good insulator because it has low thermal conductivity. In other words, heat does not travel through a layer of snow as easily as you might expect from something made of frozen water. And the reason becomes clearer when you stop thinking of snow as one solid block. Second, the hidden ingredient, air. Look closely at snow, and you are not looking at a perfectly solid wall of ice. Snow contains an enormous network of tiny spaces. Those spaces can trap air. That matters because trapped air is central to many forms of insulation. Think about a winter coat again. The coat does not protect you because the fabric possesses some mysterious source of warmth. Its structure helps hold layers of air close to your body. Your body warms that local environment, while the insulation slows the transfer of that energy into the colder world outside. The National Park Service uses this same principle when explaining insulation. Pockets of trapped air can slow heat loss. That means the wall of an igloo is doing something much more interesting than simply placing frozen material between you and the weather. It is creating a thick thermal barrier filled with countless tiny pockets where air cannot circulate freely. Picture our thermos again. You are the warm contents. The outside winter is trying to pull energy away. The snow wall adds resistance between the two. Heat can still escape. It just has a harder journey, and that distinction is critical because no shelter needs to stop heat loss completely. It only needs to reduce it enough that the heat being produced inside can compete with the heat being lost. This is where a common misconception appears. People sometimes imagine that an igloo somehow becomes warm because the snow itself starts radiating heat back at you. That is not the mechanism. The important effect is slower heat transfer. The igloo is not adding fuel to the thermos. It is improving the thermos. Third, the enemy you can feel immediately, wind. Imagine standing outside on a freezing day in perfectly still air. Now imagine the same conditions with strong wind blowing across your clothing and exposed skin. Your experience changes dramatically. A winter shelter, therefore, has another important job: separate you from moving outside air. An igloo creates a physical barrier between the occupants and the surrounding weather. The National Park Service specifically recognizes igloos and snow caves as forms of winter shelter from severe conditions. This is more important than it first appears. Your body can warm the thin layer of air immediately around you. Clothing tries to preserve some of that warmer local air, but outside wind continually disrupts that protected layer and replaces it with colder surrounding air. Think of trying to fill a bathtub while someone keeps pulling the drain open. You can keep adding warm water, but the faster it escapes, the harder it becomes to maintain the temperature. Wind does something similar to your thermal environment. An igloo puts a wall around the bathtub. Now the air immediately surrounding you is no longer being replaced as aggressively by the larger outdoor environment. You have moved from an exposed landscape into an enclosed microenvironment. The snow wall is doing two jobs at once. It slows heat transfer through the wall, and it blocks the direct movement of outside wind through your living space. That combination is far more useful than either mechanism alone. Fourth, the small room advantage. Imagine trying to warm an entire frozen valley with your body. Impossible. Now imagine trying to influence the temperature of the air immediately inside a small enclosed shelter. That is a very different problem. Your body continuously releases heat as part of normal metabolism. Inside an exposed environment, that energy rapidly disperses into an enormous volume of cold air. There is effectively no boundary keeping your tiny contribution nearby. Inside a compact shelter, there is. The igloo does not need to make the Arctic warm. It only needs to create a protected pocket around you. Return to the thermos analogy. A thermos works because it separates a relatively small internal environment from a much larger external one. An igloo does something conceptually similar on a human scale. Your body becomes part of the heating equation. Every bit of heat released into that enclosed space now has a better chance of remaining useful before eventually escaping. Add another person, and there is another source of body heat. The shelter itself still produces nothing. The occupants are producing the heat, while the structure reduces how quickly that energy disappears. This is why saying an igloo keeps you warm can be slightly misleading if you picture the igloo behaving like a furnace. It is closer to saying a blanket keeps you warm. The blanket does not manufacture the energy. You do. The blanket changes the rate at which you lose it. And an igloo applies that logic to an entire room. Fifth, the dome. An igloo's famous shape is not merely visual. A rounded, enclosed structure provides a compact shell around the protected space. But we need to be careful here. It is tempting to turn every feature of an igloo into a magical piece of thermal engineering. The strongest source-backed explanation remains much simpler. Snow provides insulation, trapped air slows heat transfer, and the shelter protects occupants from the surrounding winter environment. The dome helps create that enclosed protective shell. And visually, it teaches us something important about insulation. There is no giant heating machine hidden inside. There is just separation. Outside, exposed winter air. Inside, people, and a smaller protected volume of air. Between them, a thick layer of insulating snow. Think of three nested zones. Your warm body sits at the center. The sheltered air sits around your body. The snow shell surrounds that air. Then the outdoor environment surrounds everything. For your body heat to disappear completely into the outside world, energy has to cross those boundaries. Every boundary that slows that process buys you time. That is the game. Not making unlimited heat, preserving limited heat. Sixth, the entrance problem. Of course, there is an obvious weakness in any insulated shelter. You need a way inside. Cut a giant opening in the side of a thermos, and it stops being a very impressive thermos. An igloo, therefore, has to balance two competing requirements. It needs to separate occupants from the outside environment, but it cannot become a completely sealed container. That second point is extremely important. A snow shelter requires ventilation. The National Park Service specifically warns that people using an igloo or snow cave need adequate ventilation, especially if cooking or burning fuel inside, because dangerous gases such as carbon monoxide can accumulate and oxygen can be depleted. So seal every opening to keep every bit of warmth inside is not a safe conclusion. Thermal efficiency is not the only variable. You still need breathable air. This gives us one of the most useful lessons in the entire design. Survival systems are rarely optimized for just one thing. An igloo is not trying to become the most perfectly sealed container possible. It needs to provide insulation and weather protection while remaining a usable shelter for living, breathing humans. That changes how we should think about warmth. More insulation is useful only inside a system that remains safe. And if fuel-burning equipment is involved, ventilation becomes especially important. An igloo should never be treated like an airtight room where where combustion can occur without consequences. The thermos analogy finally reaches its limit here. You are not soup. You need oxygen. Seventh, where the warmth actually comes from. This is the final piece, and it flips the original question. Ask, how does an igloo create warmth? And you begin with the wrong assumption. Ask, how does an igloo prevent existing heat from escaping too quickly? And the whole structure makes sense. The main heat source is already inside your clothing. It is you. Your metabolism continuously releases energy. Your clothing helps hold some of it near your body. The sheltered air creates another protected layer. The snow walls create another insulating boundary. And protection from the outside wind reduces another major route by which your warm local environment can be disrupted. Layer after layer, body, clothing, sheltered air, snow, outside winter. That is the system. And notice what the igloo does not have to accomplish. It does not have to make its interior feel like a modern heated house. It does not have to melt the snow. It does not have to defeat winter. It only has to make the conditions inside less thermally punishing than the conditions outside. That can be enough to matter enormously. There is an elegant piece of physics hidden here. We often think warmth requires adding more energy. Turn up the furnace, light a bigger fire, produce more heat. But sometimes, the more powerful strategy is to lose less. Imagine two identical cups of hot liquid. Leave one exposed, put the other inside an insulated container. You did not add extra heat to the second cup, yet it remains warm longer because you changed the pathway through which its energy escapes. An igloo applies the same logic to a person. That is why the phrase, "a house made of snow keeps you warm," sounds impossible only until you identify the real opponent. The opponent is not snow. It is uncontrolled heat loss. Once you see that, other winter adaptations start making more sense too. Clothing, blankets, sleeping systems, insulated shelters, and snow cover can all be understood through the same basic question. How quickly can thermal energy move from a warmer place toward a colder one? The National Park Service has documented the insulating effect of snow in winter environments. Snow cover can help maintain a more stable environment beneath it compared with the colder, more variable air above. That is remarkable when you think about it. The surface that looks like the symbol of winter can also become protection from winter. Not because snow stopped being cold, because temperature alone does not tell you how quickly heat moves. This is the conceptual trap. Touch a metal object and a piece of insulating material that have been sitting in the same cold environment, and they can feel dramatically different because materials transfer heat differently. Your nervous system experiences the rate at which energy leaves your skin, not simply a number written on a thermometer. That is why understanding insulation requires you to stop asking only, how cold is this material? Ask instead, how easily does heat travel through it? For snow, that second question changes everything. Now zoom out and look at the whole igloo again. From the outside, you see a mound of frozen material in a frozen landscape. From the inside, physics sees something else. It sees a heat-producing human inside a protected volume. It sees outside wind being blocked. It sees an insulating wall. It sees trapped air inside the structure of the snow. It sees a barrier slowing the journey of energy from the warmer interior toward the colder exterior. Nothing supernatural is happening. Nothing needs to be hot except the organisms inside. And this gives us our first major myth bust. The igloo does not work because snow is secretly warm. It works because snow can be a useful insulator. Second myth, an igloo has to become extremely warm inside to be useful. Number. The relevant comparison is not between an igloo and your living room. It is between the protected conditions inside and the exposed winter conditions outside. Reducing wind exposure and slowing heat loss can make the shelter valuable without turning it into anything resembling a heated building. Third myth, if keeping heat in is good, completely sealing the shelter must be better. Again, no. Humans need ventilation, and combustion inside a poorly ventilated snow shelter creates serious danger. The National Park Service explicitly warns about carbon monoxide and oxygen concerns in winter shelters. So the brilliant part of an igloo is not perfect isolation. It is controlled separation. Enough separation to slow heat loss. Enough shelter to block severe weather, and enough ventilation to keep the space usable safely. Now return to the person standing outside at the beginning. The environment has not changed. The winter air is still cold. The snow is still frozen. Your body is still producing heat at roughly the same basic biological task it was performing before you entered the shelter. But the pathway around that body has changed completely. Outside, your heat is released into an enormous moving environment. Inside, you are surrounded by a much smaller protected volume. Outside, wind can continually disturb the warmer layer around you. Inside, a wall blocks that direct exposure. Outside, there is little between your body and the broader environment except your clothing. Inside, you have added an entire shell of low conductivity snow around your local environment. Same person, same winter, different heat loss system. And that is why the igloo is such a powerful teaching tool. It demonstrates that surviving cold is not always about producing more heat. Sometimes, it is about engineering the route that heat has to travel. Your body is already the furnace. The shelter is the resistance. The snow is not fighting its own temperature. It is simply slowing the exchange between two environments. Think of the igloo one final time as a giant winter jacket. The snow wall is the insulating layer. The trapped air inside that structure helps resist heat transfer. The enclosed interior keeps your body heat in a smaller protected environment. The shell blocks the surrounding weather. Your clothing adds another insulation layer directly around your skin, and your metabolism keeps supplying the energy that the entire system is trying to preserve. That is the hidden mechanism. A successful cold weather shelter does not need to defeat the temperature outside. It needs to change how fast that temperature can steal your heat. And this is why one of the coldest materials in the landscape can become part of a shelter that protects you from the coldest air around it. The next time you see an igloo, don't picture a frozen house somehow generating warmth. Picture a thermos with a human heart beating inside it. The person supplies the heat. The snow buys the time.